So we have y equals a times b to the x power. And so you guys saw the same formula yesterday on that Edpuzzle video that you were watching for me. That a right there is going to stand for your initial value. So it is the amount that you start with. B is your either growth or decay factor, and we'll talk more about it here in a second. And X is some sort of time. It might be hours, it might be days, it might be seconds, it might be the number of rounds in a tournament, but it's some way of measuring time. So yesterday you were looking at growth. So for growth, for the B, you needed to do 1 plus your rate as a decimal. So if you are getting 2% interest on a savings account, it would be 1 plus 0.02, right? The rate as a decimal gets added. If we have decay, then we are looking at something that is decreasing exponentially, and the way that we'll do this is we'll do 1 minus the rate as a decimal. So, yesterday you were looking at situations where your amount was increasing. So this might have been like population increasing, number of bacteria increasing, save money in a savings account earning interest, right? Those are all different types of exponential growth. Today we're going to look at some for decay. So questions here, everybody got it down? This is definitely note card material also. You want to make sure you've got this formula on your note card somewhere. There. So the first thing that we're going to talk about is depreciation. So depreciation is what happens to a lot of things that you buy in life, right? Once you buy it, what happens to its value? Goes down, right? Lots of things that you buy in life, that's what's going to happen to it, right? Particularly, your probably biggest purchase that is going to depreciate is a car. Cars go down in value pretty much across the board, right? The only time you're going to have cars that increase in value is if you're talking about classic cars, or really weird scenarios like during COVID, used trucks were selling for almost more than new trucks because there was a shortage because of the chips and like weird stuff like that. But in normal time, the value of a vehicle is going to depreciate unless it is a classic car. And even if it is a classic car, if you drive it every single day, it's probably not going to increase in value because whenever you drive a car, you're putting more miles on it, there's more wear and tear. It's going to be worth less money. But if you keep it in the garage and just rub on it and take pictures with it, then it will go up in value. But whenever you buy a vehicle, it is going to depreciate exponentially. Okay, so I'm going to pull up a Desmos graph here so we can like think about what's happening to the numbers with this one, because since you guys are mostly of car buying age or getting very close to it, right? I think this is a really good thing for you to know. So what's going to happen here is you are going to buy your car. It's going to cost $28,750. Each year, the value is going to decrease by 12%. So let's think about it this way. If the value decreases by 12%, what percentage of its value is it keeping? It loses 12. What percent does it keep? 88, right? 100 minus 12 gives us 88. So that would mean after a year, I've got 28. Let me make this so you can see it pretty good. 28,750. So at the end of the first year, if I multiply that by 88%, now the car is only worth 25,300, right? And then so if I take 25,300, the next year it's going to get multiplied by 0.88, and that's going to be 22,000. So like this first year, 28,750 minus 25,300. The first year, I lost $3,450 in value. Right? The next year, 25,300 minus 22264. The next year, I only lost about 3,000. Not quite as much, right? Because the percentage is the same, but the value was less. And so if you keep on, like if you take 22264 and multiply it by 0.88, the next year you've got $19,592. Well, if you look at 22264 minus 19,592.32, that was only $2,671. So that is why, like some of you, if you are driving a 1995 Honda Civic, right, that has 250,000 miles on it, your car is not dropping. If you can keep it running, it's not dropping that much in value, right, because it's already not worth very much, so 12% of that is not much. But when you buy an expensive vehicle, 28,000, I mean, you know, everything's relative here. That's not a cheap car to me at all, and definitely as a teenager, to me that would be like a really nice car to buy for a teenager, right there. You know, if you're talking, let's talk like, you know, $100,000 SUVs, right? People go spend $100,000 on an SUV. If you go spend $100,000 on an SUV, that also loses 12% per year, that first year you lose $12,000 in value in that first year if it depreciates at that rate. Cars depreciate at different rates for a lot of different reasons. There are some cars that hold their value better than others. So like if you buy a very like reliable, reputable brand of car, it might hold its value better. It may only depreciate at like 6% or 10%. Whereas if you buy something that's known to fall apart, it might depreciate at 20% each year. So it depends. It also matters how well you take care of the car. If you don't take very good care of it, it's going to depreciate more quickly. So I say all of that to give you the life lesson that a car is not an investment, or if it is, it's a terrible investment. You're going to lose money on it every time unless you don't drive it. We got to have them, but you're not going to make money off of your car. The only time you're going to make money off of a car is if you're improving it somehow and reselling it, which takes some work. If you're just buying it and driving it, you're not going to make money unless somehow you're really lucky or you're able to sell it to somebody really dumb. You're not going to make money most of the time on a vehicle. It is going to decrease in value. This question here, I think it's printed incorrectly on your page, and that second number right there is 2018. Change that to 2024 for me, because it doesn't make sense for me to tell you how much it costs in 2018 and then ask you how much it cost in 2018. That was a mistake on my part. For this, we are going to look at an equation. So y equals what here, Sophia, would be my initial value? What? Very good. 28,750. That is my A value. That's my starting value. To find that B value, when we're talking about depreciation, we're talking about decreasing in value. So we're going to do 1 minus the rate as a decimal. So, Cannon, what is 12% as a decimal? Yep, 0.12. And if we subtract that, we will get 0.88, which, keep in mind, is like 88% as a decimal, right? So it's the value that the car is retaining right there. So we've got 0.88, and that'll be to the x power. In this case, x is years, thank you, and y is the value of the car. Okay, so he bought the car in 2018. It is now 2024. So, Sophie, how many years have passed? From 2018 to 2024. Six years. Good. So 6 years have gone by here. And so the X is your amount of time. That's where you're going to plug that in. So we're going to be doing 28,750 times 0.88 to the 6th power. And so if we pull up that Desmos there, we do 28,750 times 0.88 to the 6th power. We're going to get $13,351.62. And that would be the value of the car at that time. Another option here, as far as Desmos goes, is that we can do this. Like, we know our equation is y equals 28,750 times 0.88 to the x power. If we do x equals 6, we can look for where they cross. But because that number right there is so big, you would have to make your y like 30,000 to be able to see it. But there you can see where it crosses, and it is at $13,351.62 for that. So you can see, like, 6 years, car is worth less than half of what it originally was worth, all right? So cars, and that's, I didn't look up any specific type of car for that, but that's pretty realistic for a lot of vehicles. So you want to keep that in mind whenever you are purchasing a vehicle. Just think, like, if we change this to that $100,000 SUV in 6 years, right here, that thing's only worth $46,000. So you've lost like $54,000 in 6 years. It's a lot of money. You should definitely not do that unless you just have $54,000 to lose. There, because that, you know, you think, you wouldn't do that on anything else. Like, you wouldn't be like, you know what, I'm going to put my money in something that I'm going to lose $54,000 in 6 years. That would be bad. So, now, if you've got lots of money and you really want this vehicle, it's really, I'm sure they're nice. I'm sure they are nice. I don't doubt that they are great, but that's not even considering the gas for them either, because they get super bad gas mileage. But important things to remember there for that. That is why I have the Sedona out there, because the minivan is the cheap option for version of an SUV. It's much cheaper than buying an SUV. Can't pull anything with it, but it gets better gas mileage, and it has about as much room on the inside. So, and you look super cool whenever you're driving your kids to different things. So, minivan, yeah, minivans are the greatest. My minivan is more useful than my husband's truck. He just got like a mid-size truck, so he's got like a Colorado, and you know the bed's only like 5 foot long. You can't fit anything good in the bed. It might blow away if it's in the back of the truck. You gotta tie it down. It might get rained on, but I can put those seats down in my van, and you just put it right in there. I mean, we put furniture in there. Put a whole mattress in there one time. Like you can fit so much stuff in a minivan, and you shut the hatch, and it doesn't get wet whenever you drive it. It's not very good if you want to go off road. That is not going to work very well. And I wouldn't want to put like a deer in the back of it. It's a good thing it's got a truck for things like that. Wouldn't want to load up the deer in the back of the minivan to take to the processors. That wouldn't be good. But for what I need it for, it's the best. Would a $100,000 Escalade be nicer? Probably, but it's a little out of my budget. There, so yeah, a little out of my budget. So we'll stick with the minivan. It'll get us where we need to get. Plus, minivans got those side doors. Kids can't open them into people. You pull up in car line, you hit that button. It's automatic. Huh?
Can I hit the button while you're driving?
No, you have to be in park. Yeah. Which, if they didn't have that safety feature,
When you're at the stoplight, well, you don't go park.
you can child lock the back doors so they can't get in and out. So you can turn on like the child lock so that they can't open them. I don't think I have that on. Mine are a little older now, but you can child lock them. I got the child lock on the windows.
2018 or 2019?
Yeah, 2019. Yeah. Yeah, I got the windows locked because Henry just wants, even at 8 years old, Henry just wants to roll the window up and down and up and down and
I
up and down.
have 2009. I still have the crank windows.
Really?
Yep.
I remember some crank windows from my childhood. Yeah.
You said the same?
Some crank windows will build some character. That's good for you. Yeah, that'll build some character.
It does build characters. I never drove. I wish I had.
Yeah.
And like they're not like all windows like whenever you like put them, they all roll up instead of having like holes.
Because like your car is so nice.
They get 12 miles a week.
Yeah.
Oh,
Yeah.
yours.
The trucks. Pretty good.
I don't have a car because I don't ever drive, so I can't get my hours in.
Yeah.
I hate driving.
Really?
I want to start right now. I have my
Now, when I was 16, I was so excited about driving.
I mean, I love driving. I never wanted to get licensed. But mom was like, you're being foolish. So you have to go get it. Like,
Yeah.
now, you wait till you're 18 to get it. You're already going to get it.
Yeah.
You can take me.
Trust me, as a mother who has to drive their child everywhere right now, go get your license. It's yeah, there's a lot of driving around that I do right now. I'm a taxi driver. Because definitely around here, you pretty much have to have a car to be a functioning adult, or you have to live close to where you work. And close to a grocery store, or you're going to be out of luck. So, yeah. So we definitely don't live in a part of the country where you can get by without driving much. Okay, let's keep going. All right, this question is very similar, but it asks a different question at the end. Okay, so let's set up our equation. Setting up the equation is going to be pretty much the same. So, Caden, in this case, Mark bought a brand new car for $35,000 in 2008. If the car depreciates in value by approximately 8% each year, in what year will the value of the car first drop below $1,500? So, what is our A? What is our starting value here, Caden? Good. So we got 35,000. And then we have to find our B value. And since this is depreciation, we're going to do 1 minus. What is 8% as a decimal? 0.08. So whenever we do that, we'll get 0.92. So we got 0.92 to the x power. And just like the last problem, x is our number of years, and y is our value of the car. Okay? So, in this case, they didn't give us a number of years, right? They didn't say how many years have passed. They're asking us when the value will be below 15,000. So the value, is that an x value or a y value? It is a y value, right? Because that y, that's one reason I kind of like to write out what these stand for, because it reminds you, oh wait, this is a value of the car. It's got to go in for the y. So that means that we're going to have 15,000 equals 35,000 times 0.92 to the x power. So we have two options for solving this, okay? So we know how to solve this one by hand. We'll need the calculator to get the exact value, but we know how to solve this one by hand. So Emma, if I'm trying to solve for that x right there, this 35,000 is the first thing I need to get rid of. What do I need to do with it? Divide it. So I'll divide by 35,000. And we're definitely going to need some Desmos to get the exact value. We don't want to get fractions anyway. So we got 0.42857. Equals 0.92 to the x power. So now we got 0.92 to the x power. We're trying to get rid of that 0.92. How are we going to do that, Maze? Not divide. Because it is not 0.92 times x. We got to log it, right? So we're going to log with a base of 0.92. Log a base 0.92 on both sides. So our x is going to equal log base 0.92 of 0.42857. I don't know why it's doing that right there. And so if I type that in, log base 0.92 of, let's just copy and paste this number right here, I get 10.162. So 10.162 years. Now that's not quite my answer to the problem. Because what did the problem ask me? In what year? So if you answer the question, in what year does the car drop below 15,000? With 10, you're telling me in the year 10. We don't really mean in the year 10, right? We really mean 10 years after the car was new. So what would we do, Sophia? It'll be 2018, because we'll do 2008 plus, technically it's 10.162, but that's going to be during 2018, right? It's going to be during that year. So 2018 would be our answer for that. Okay. Perhaps you've forgotten how to solve exponential equations, and what I just did seemed confusing to you there. That is okay. There is also a Desmos way to do this. So let's say that you are lost on this. Let's say that you need to use Desmos entirely for this. You still have to be able to set up the equation. If you can't set up the equation, you're going to be in trouble. We got 3,500 times 0.92 to the x power. So you have to be able to do that. And then you are going to do we're doing a y value right here equals 1,500. So if I do y equals 1,500, I see nothing right now if I'm in that like standard view. That's because what number do we at least need to go up to on our y-axis? What do we know the car was at least worth? What's it start out at? 35,000, right? I need to go up at least to 35,000 to be able to see this graph. If you zoom out, here's the problem. Like, it will zoom out, but by the time you get zoomed out enough to see that purple line, it's not easy to see. Now, it is giving me the right answer, but it's also very easy to accidentally click on like the y-intercept right there. So here's what I would do instead. All you really need are more y values for this. So if you hit the wrench right here and see where it says y-axis, go right here. That's the upper bound of your y-axis. Change it to 3,500 or 35,000. And then you can zoom in or out a little bit from there, and you'll have a graph you can see for that. And so, see, we're getting that 10.162 there as well. So if you don't know how to solve it by hand, you certainly could just use the Desmos for it. Okay? Questions? Okay, a couple other scenarios that we're going to look at here for this. Here's another situation that is exponential decay. So when you take some sort of medicine and you ingest it into your body, your liver, your kidneys, you know, the organs of your body that filter out things start filtering out that medicine, right? So if you take 400 milligrams of ibuprofen, I'm making this up. I do not know how quickly ibuprofen goes out of your body, so that is a disclaimer. I know that it happens in this manner, but I don't know the exact numbers. I'm not a medical researcher with these, so don't use this for medical advice. But that is going to process out of your body, right? And the way it works is like every little bit it filters out this amount. So it decreases exponentially. So if we're writing an equation for this, we're going to have y equals, our initial amount is 400 milligrams of ibuprofen. Our B value in this case, we are using up the medicine at a rate of 30% per hour. So if we do 1 minus 0.3, we will get 0.7. So much like our car problem, if we lose 30% of the medicine, we're keeping 70% of the medicine, right? 70% is still in your system. And then we raise that to the x power. In this case, x is hours, and y is amount of ibuprofen. Okay? So if we want to know how much is in the system after 4 hours, then we need to plug in 4. Carson, do we plug it in for the x or for the y? The x. So we're just going to be doing 400 times 0.7 to the 4th power. And if we do that in Desmos, over here, we get 96.04 milligrams. For that, let's look at the graph of this. I'm going to change that back to an X. Let me hit the house button. All right, now, if I'm trying to get a good graph of this that I can actually look at, then I can see it some over here, but I start with 400 milligrams. So I need my y-axis to go up to 400. So if I adjust that, I can get a graph that I can see better. So if I look at this graph, theoretically, is the medicine ever gone? Theoretically, no. Because like out here, even like 24 hours out, I still have 0.07 milligrams in my system. Is the ibuprofen doing anything at those levels? It's not helping you any, right? If you had a headache, the headache's back, right? It's not doing anything, but you still have trace amounts, right? Now, I am not sure at what levels ibuprofen is detectable, but if you were to go out this weekend and make some questionable life choices in which you ingest illegal substances, this weekend you'll be up here and you will be riding high right here. And over time, it will decrease, right? And then you're going to be down here and you will not be riding high anymore. You will feel normal again. But then, over here, a few days later, a week later, maybe 2 or 3 weeks later, they are going to call you up to the office, and they're going to say, bring a bottle of water if you have one. And is it gone? No. I mean, you don't feel the effects of it, but it's not gone. So when your kidneys are flushing out little tiny trace amounts, it's going to trip the drug test, and they can tell, right? That's why drug testing works, is because there's still teeny tiny trace amounts, even though you're not still actively under the influence of that substance there. So that, like, exponential decay is the reason that works. Now, eventually it's going to drop. You saw over here I had to go back because I got over here and it did actually say 0. Desmos has kind of like reached its limits there because it can only like keep 10 decimal places. Eventually, it does get low enough that it's not going to be enough to trip a drug test. So eventually, but I think they warn you like even like a month out, sometimes it can still trip that test. I don't have any personal experience with that, but I hope that none of you do either. But exponential decay is the reason that works like it does. So make good life choices, everyone, and don't do drugs. Another, and this is like, that's also very, very important. Like, this can be really important because if you're taking ibuprofen and you take more than you're supposed to, like, let's say that it's only been 3 hours since you took ibuprofen and, you know, your headache is killing you and you go ahead and take another dose. That is not recommended, right? But those, like, labels have a level of safety built in. So if you take it a little bit too early, it's not best for you. It's not what you should do. I'm not telling you that it is what you should do. Is it going to kill you? Probably not, right? It's probably over time, if you do it all the time, if you're constantly taking ibuprofen all the time, not by recommended labels, it's not going to be good for your health. But there's a level of safety built in. But if you go to the hospital and you have surgery, how many of you had surgery before where they knocked you out? If you go to the hospital and you have surgery, they're not giving you ibuprofen, right? Whenever I had to have like an outpatient procedure, and the doctor, it was the doctor, not the anesthesiologist. He was in there, but the doctor let me know that they were going to be giving me whatever drug that they gave me to put me to sleep. And then he added that it was Michael Jackson's drug of choice, which was not funny because Michael Jackson died from an overdose of that drug, and they were about to give me that drug. So anesthesiologists, many of you probably know, like, they're some of the highest paid people in the hospital because they are giving you deadly drugs. I can't remember the name of it. I'm sure you could Google it, except for I got you on lockdown right now. I wouldn't just in case. Yeah. But it is, Michael Jackson was paying doctors because, Michael Jackson was just infinitely rich. He was paying doctors to give him, like, he was getting IVs of this drug, like, at his house. So, like, he was on legal medicine, just he shouldn't have been because they were giving him way too much of it. So it wasn't like he was buying it on the street and using it. He just had, like, his own, like, personal doctor that would give him whatever he wanted. So this would not be, like, the type of overdose death a poor person could afford to have. Anesthesiologists are giving you deadly amounts, not deadly amounts, deadly drugs. Like, if they're wrong, it could be terrible, right? So that is why anesthesiologists have to go to school forever. What they're doing, they need to be very, very good at. And then they have lots of checks and balances to make sure levels of safety built in. That's why they need to know how tall you are, know how much you weigh, because if you are given an amount to a 98-pound female versus a 300-pound man, it's going to, you're going to need different amounts. They have to know a lot of different things for that. It's a very, high stakes kind of job. I could teach you how to do exponential decay completely wrong. I could teach you everything about it wrong. I could have you, everybody in class is getting wrong answers. And I wouldn't be good at my job, but you would all still be alive at the end of the day. Anesthesiologists, not so much. So, whenever they're making calculations for this, I know a lot of you were, interested in nursing. Nurses aren't given the put you to sleep kind of drugs, at least not without being under the supervision of an anesthesiologist. But nurses have to do a lot of calculations on drugs and give the correct amount to a patient. So you would not want to make calculations incorrectly, think more of this is out of their system than is, and give it to them too early, and all that stuff. So it's very important. Now, this is probably more on the research end of it. If a new drug is developed, they have to study how quickly this is going out of a patient's body, and so they can set recommendations for it. Nurses are probably mostly following the written recommendations that a drug gives you, although there's still a lot of calculations that have to be made. So very important stuff right there too. Last one we got is half-life. Half-life is a term that is used a lot in science, specifically with radioactive decay is one of the places that you see it, but anything that's deteriorating, it could be used for. So the way a half-life works is it's the amount of time it takes for half of a substance to be gone. Have you guys seen that in science classes before? So, the half-life of this made-up radioactive substance is 7 hours. A scientist has an initial amount of 600 milligrams. How long will it take until there's only 5 milligrams left? So I'm going to make ourselves a table just so you understand what's happening here. So the hours that have gone by are here, and the amount is here. So at 0 hours, you have 600 of this substance. 7 hours later, one half-life later, 7 hours, you would only have half. You would have 300. And then another 7 hours would go by. You'd be at 14, and you would have 1,000 or 150. And if we kept on with that, at 21, you would have 75. And I could keep on going with this, but even after here at 75, I'm going to start getting decimals whenever I cut that in half. I'm not going to be able to get the exact answer for what it's asking me for this 5 milligrams by making a table, because I'm going to start getting decimals after this. I could get a good guess for that, but I'm not going to get the exact answer. Who was that? Oh, they've got 3. We're going to let them in. Thank you. Oh, this is honeycomb cake.
Yeah, we can try.
It did fall apart a little bit, but that's all right.
Mine's better. It's more hot.
No, it's okay. This looks like it's got more stuff in it. This one I think might be best. Thank you, guys. Trash can. Turn it the other way. Yeah, thank you. All right. I was afraid we had an invader there for a second. Yeah. All right. So in this case, what we're going to do is y equals 600 is our starting amount. What are we going to use for our b value here? Because we don't have a percentage. We don't have a rate for this. I think I heard it. What? 0.5. Why? It's half, right? So half is like the word that is telling you the rate there. And half is the only time it doesn't matter if you do the B value correctly, because half is 50%. So if I do 1 minus 50%, which is 0.5, I get 0.5. So it's the only percentage where it doesn't really matter if you subtract it or not. So I've got 0.5 to the x power. Now, what we've got to know for this, it's a little tricky, is that that x right there is not the number of years, it's the number of half-lives. And then y is your amount of your substance. So like over here, your half-lives would be 0 here, and then you got 1 half-life, 2 half-lives, 3 half-lives, and so on. So whenever we get an answer for this, it's going to be half-lives. It's not going to be like the actual amount. So in this case, I want to know how long it's going to take until there's only 5 milligrams. Where does that 5 need to be plugged in? Is it plugged in for an x or for a y? Is it a number of half-lives or is it an amount? It's an amount. And if you see the question saying how long, the number is going to get plugged in for the y, right? Because the question is asking for the x. There. So this gets plugged in over here for the y. I've got 5 equals 600 times 0.5 to the x. For the sake of time here, let's go over here and do this on Desmos. So I've got y equals 600 times 0.5 to the x. I also have, I'm going to say y equals 5 right here. Hit the house button. And I can actually see where that one crosses. I'm getting 6.907. But that is not hours. That is half-lives. So half-life problems are usually ones that kids miss a lot because they give this as their answer. That's our number of half-lives. How long is each half-life? 7 hours. So I have to take my answer, 6.907, and I have to multiply it by 7. And if I do that, if I take this number here and multiply it by 7, I'm going to get 48.348. And that is my, that's not right, 48.348 hours for that. All right, we did not get to compound interest. So your assignment that, we still got 8 minutes, so I want you to flip over to Delta Math. I'll cut off the class-wise so you can get there. On Delta Math, if you'll flip over there, you're not going to be able to do the entire assignment because we didn't get to compound interest. It won't take us long. We'll do it at the beginning of class tomorrow, and then we'll work on reviewing. No, I need to go here. So you guys are going to do this 2.6, 2.7 assignment for me, but you only have to do the ones that are called basic, okay? The thing that you have to be careful with here is it asks you to round a little funny on these. It's definitely not all like 3 decimal places like I normally do. So like this one's to the nearest minute, so it would be the nearest whole number, okay? So so you've got 5 questions that you got to do. Go ahead and try to get as many of those done now as you can, and then we'll pack up.